Hello everyone, today we're going to be talking about our rational root theorem. So up until this point I've given you one factor and therefore you could figure out one root of a polynomial, and then from there use that information in order to figure out the other roots. So today we're going to be starting basically from scratch. I'm not going to be nice to you anymore. We're taking off those training wheels and I'm just going to give you a function and ask you to find all of their roots on your own. So in order to do that, we have to use our rational root theorem, which will tell you all of your possibilities for your roots. And then through those possibilities, it's just a bunch of trial and error in order to figure out which ones work and which ones don't. So I'll show you wherever I can find shortcuts. I'll let you guys know because this can be kind of a long and tedious process. So let's start by figuring out what are our possibilities. In order to get those possibilities for our first function here, we're going to have to take a look at our last term, our constant term, find all of those factors, and divide that by all the factors of the leading coefficient. So in our first example here, the 2x cubed plus 3x minus 5, the constant term is 5, so the factors are plus or minus 1 and 5. The leading coefficient is 2, so the factors there are again plus or minus, and then 1 and 2. So we can write our possibilities just like we have here. And then all of our possibilities, looks like if we divide 1 by 1, well, that's 1. If we divide 1 by 2, that's 2. If we divide 5 by 1 is 5, and 5 divided by 2 is 5 halves. So we actually have 8 possibilities for factors because we have to test both the positive and the negative for those 4 different factors. So we have choices from here. You can either do a synthetic division or a synthetic substitution, whichever method that you prefer. Both work for you here. So let's just say that I'm going to choose to do synthetic substitution. I'll choose actually synthetic division for this one. It's not that bad. It's only 3 terms. So if I try to test 1 first, so I'm going to bring down a 2, I'm going to multiply and add, and oh, today's my lucky day. Since I got 0 as a remainder, I know that 1 is one of our factors. So x equals 1 is definitely one solution. Now, how many solutions do we have as a possibility? We have to look to the degree of our function here. Since we're looking at a 3rd degree polynomial, that means at most we will have 3 factors, right? We'll have 3 x-intercepts at most. I found 1. There could be more or there could not be. We don't know yet. We have to keep testing the other 7 options. So to show you how to do this on the calculator, if you have your graphing calculator with you, we can go ahead and start testing some possibilities. So let's say -1. We still have to test that one. So -1, I'm going to store that as my x value. Hit enter to confirm, and then start typing in my equation. So 2x cubed plus 3x minus 5, hit enter, and it looks like when we do the synthetic substitution there on the calculator, we get -10 as a remainder, and therefore we know that that is definitely not one of our roots. Cross that off the list. So let's start testing the next one. Next option would be a +2. So 2, store, x, enter to confirm. Now from here, you'd have to retype your equation, except if your calculator allows you to use your up arrow to highlight a prior selection, we're going to highlight that equation and hit enter. And now see how our answer changes from -10 to 17. That's because we evaluated for a new x value. When x is +2, that means in our function, the output would be 17. Again, not our root, so it doesn't help us here, but that's how we can have a shortcut. It saves us the time of rewriting that equation, especially for longer equations. That can save some major time. Let's type in -2 just so you can see it one more time. -2, store x. Use my up arrow to highlight my equation. Hit enter. Again, -2 is not going to work for us. So we're halfway through testing all of our possible options. So you can keep going through this method, but for the essence of time in this video, I'm not going to test the other ones because I actually know that they don't work. We actually only have one answer here. And how do I know we have one answer? Because I took a look at our function in my calculator and I saw that there was only one x-intercept at +1. So that +1 x-intercept reconfirms the algebraic answer that we got here, that we got a root of 1. All right, let's take a look at a second example. This one's a little bit longer of an equation, but it's fine. We can do it. At most, since we're looking at a 4th degree polynomial, we know we're going to have 4 possible roots. So take a moment, pause the video, see if you can write out the possible rational roots, all those factors of our constant term divided by the factors of the leading coefficient. We'll reconfirm that piece before moving forward. So go ahead and hit pause. So factors here, we're looking at plus or minus. And then we have the options of factors of 12 are 1, 2, 3, 4, 6, and 12. Our leading coefficient is just 1. So it looks like here we actually have 12 different options to test out. And at most 4 of those 12 could work. So we can go ahead and do some of the divisions again. Your choice, synthetic division, long division, until we find some that work. I'm going to use my little cheat on the calculator. So that should save me hopefully a little bit of time. So you can go ahead, pause the video if you want to try this yourself, and then we can come back together when you are ready. Let's see. Clear out what I have here. I have x to the 4th, and then scooch out of that exponent, 2x cubed minus 7x squared minus 8x plus 12. That's my function. All right, so let's start testing values. -1, store that as my x. Plug in my equation. -1, not a factor. How about +1? Is +1 a factor? Let's plug in my equation. 1 works for us. So as I find one that works here, I'm going to want to keep bringing down our quadratic into something that we know how to solve, or our 4th degree polynomial. Sorry, I'm trying to get that down to a quadratic. So I'm actually going to use the fact that 1 is a factor in my division here. So 1, 2, -7, -8, 12. So bring that down, that's a 1. So 1, 3, 3, -4, -4, -12, -12, 0. So that's a beautiful thing. So I know I did that piece correct. If I throw my variables back in there, always 1 less degree than what you started with. So I now have this cubic here that I can go ahead and keep testing. So I tested +1, I tested -1. Let's look at 2. Let's see, -2, if I store that as my x value. And then look at my equation. Oh, that one works for me as well. Awesome. So I'm going to do -2 then with this equation here, right? Once I do this division, then I'm going to have a quadratic. So I'm going to bring down my 1. So -2, +1, -2, -6, +12, 0. 1 less degree than what I started with. Here I had a cubic. So that means here is my quadratic. All right. So now I'm looking to see, can I factor this? Are there factors of 6 that have a difference of 1? Yes, there most certainly are. We're looking at x and x, a +3, a -2. If I wanted to write out all my factors here, this factor would be an x plus 2. And then this factor here would be an x minus 1. So all the roots of my polynomial then, my x-intercepts are at 1, -2, -3, and +2. So I've actually gone ahead and graphed this as well, so that we can confirm that we have x-intercepts at -3, -2, +1, and +2. All right, some of these problems definitely take longer to do than others, but we have a way of confirming our answers on the graph, and we can use our calculators whenever we need to for a little help in our algebraic process. All right, thank you so much for watching.